Yeah, that's what I was looking over here, firing it up on my laptop. 16 viewers. This is what gets me is, this is the time to really get help on all the lecture questions that a good portion of the class is stressing out on all week, working on these things, trying to get caught up. To not even come to these lectures, I don't know. It, I don't. It kind of like I have the incentive to have that review session on Friday. People ain't even coming to the lectures. I guess that's not a strong incentive. But maybe they'll show up once it hits 150. I don't know. But also the post for review, like what should we review, hasn't really gotten much traction either. I'm having trouble with the constructor for 4.1. Again, like, did you post that on the Piazza? I guess we have chat too, so I guess the Piazza's, the utility of that is lessened. But I do have some I'll go through today, the ones that got the most votes on Piazza. Do we have to write actual tests for our project contribution? No. Like, you should test, like, it should work. You should test it. You don't have to have unit tests. That's not what I mean for that. But you should make sure that it works. Like, if you're changing something on the front end, you better pull it up in your browser and make sure that change actually happened. Like, I shouldn't, if I take your coding contribution and fire up the server and open up the browser, like, I shouldn't get errors. It shouldn't be broken. However you want to do that. What's up, P? What's up, Nash? What's up, Odip? Free pizza, please. I don't think the free pizza is going to happen. It's one thing I really miss with online lectures and online everything. No free pizza. Ooh. Oh, man. I don't know why I'm so tired. Yeah, you be Marcos. I thought that I wanted something, because all the incentives are, hey, if you don't have an A, here's some chances to improve your grade. So I wanted something in there for those of you who already have A's locked up. Is to stream if we hit 90%. So we're here, I'll refresh right here, but we're kind of stuck on the response rate. Stuck at 53% right now. And I already sent, I fired off my big shots yesterday. I did the Piazza post, I emailed the entire class, and then I went into the eval site and had the eval site email anyone who hasn't filled it out yet. So that was my big push. If they ignored all that, a student who ignored all of that by now, I mean, it hasn't quite been 24 hours, I don't think, since I did all that push, but Mega Muni. What's up, JS? It was this Java. This is Scala. What's up, RT Keenan? So, for those of you who did miss all that, hopefully there's a few of you here who didn't see any of that yesterday, so we can get this response rate up. But I gave some incentives to fill out the course evals, to give feedback on the course and let me know how it went. Anything I can do to improve, especially, is very valuable feedback, especially with this online-only semester. What would you have liked to have seen in the course is the biggest thing that I want to know from that form. What can I do to improve next semester? Because next semester is going to be remote as well. So I have some incentives to push you to the class to get that. The only information I get is the percentage of how many of you have filled out that form. Once you hit 60%, if you hit 60%, the incentive is, I think, pretty big. You can do 3 expansion objectives instead of just 2. So especially anyone who's sitting at an A- max, missed one of those homework deadlines, you can still earn an A in the course if we hit that incentive. It's one of the big grading structure changes if we hit that. We're at 53 right now. I hope we at least hit that one. If not, I'll be kind of bummed. But if we do hit that one, I'll also extend. I didn't put this in the post, so breaking news. I'll also extend the application objective deadline, so you have more time. You can't find out Friday that, hey, you can do another application objective and then just have the weekend to do it. So I'll give you more time to do that as well. That also comes with I'll spoil a lecture question in Friday's lecture. If we hit 60%, I'll have a Piazza post if we hit 60% to say which lecture question do you want me to just spoil, and I'll go through the entire solution. I'll code it up just like I'm a student. I'll look at the lecture question, go through the code, and just solve the whole thing right in front of you. So it's a free lecture question. If we hit 80%, same thing, but I'll do 2 lecture questions, and also I'll host a review session on Friday. If we hit that, I intend for that to be a late night session, roughly 8 to 12. If I want to do a whole 4 hours, roughly 8 to 12 p.m., 12 a.m. technically. So those last 4 hours before lecture questions are due, I'll be on stream answering your questions while people are in panic mode, saying, how the hell am I going to get these lecture questions done? I'll be here chatting. You can ask questions like, man, I'm stuck on 3-4. And then I'll be like, oh, 3-4, let's talk about it. And then you can ask me questions. I'll do that for hours leading up to the deadline if we hit that 80%. And then 90%, and also spoiling 2 lecture questions on Friday instead of just 1. And then Friday, let me check, did I say 3 lecture questions if we hit 90%? I mean, we're not hitting 90% anyway. I have some faith, but not after we got stuck at... we're stuck at 53% here. I'm losing my hope for that. But if we do, I'll host a gaming session next week, sometime next week. We'll hash out the details if that is looking likely. So far, somebody suggested streaming Cyberpunk 2077. I checked out the trailers. I've heard of this before. It's been talked about in chat, and yeah, the trailers look amazing. I'd be happy to do that on stream. Even if that doesn't get met, I might play that game anyway because it looks dope as fuck, and that's something I might. Sorry, excuse my language. It's something I might play anyway. Just off stream though. But if I'll play it on stream, unless somebody has other suggestions. If you want to play like Among Us as a class or anything like that, we can set up Zoom with breakout rooms, whatever you want that to look like. If we start approaching 90%, and I didn't list it, I guess I should update this a little bit. But 90%, I would also do the Friday review session in addition to the gaming stream. I guess technically the way I have it written up, you might think that the gaming stream would replace the review session. That's not true. I would do the review session in addition to. Hopefully I'll get the course evals out. And I would assume everybody who's here has already done that. We do have quite a bit here. 45. All right, the viewership is going up. So hopefully everybody here is getting that done. Hopefully this number goes up over the course of the next few minutes. If you have not filled out the course eval, just do it right now. You can watch the VOD and catch anything that you missed while you were doing it. Just fill it out. Get that done. It's important to me. It's important to the university. It's important to the School of Engineering and Applied Sciences. And I got, I think, pretty good incentives. Some semesters I've had pretty weak incentives. If you look at my 442 incentives, I don't know if you have access to that. My 442 incentives are pretty weak, I think. They're not very strong incentives. I think my incentives for 116 are pretty strong this year. Hopefully that pushes a pretty high response rate. And y'all have been calling for gaming. I don't know if it's joking or not, but hey, if that's something you actually want, give me something I want, and I'll give you something you want. Yeah, I don't have a 3090 though, so hopefully it runs. If it comes down to that, hopefully my graphics card can run it, even if I play it offline. 5v5 League of Legends. I've never played it, so you'll kick my ass, but I'd be down for it. If that's what the people want, it's what the people will get. If you give me 90%. Yeah, Piazza poll. The problem is the people who haven't filled out the eval yet probably aren't checking Piazza. They're probably busy with other projects, other courses, studying for other things. They probably haven't gotten to those emails yet. I'd like to think students wouldn't open that email, read it, and then still not fill out the course evals. It's the students who just are completely unresponsive. Those are the ones we have to get, and it's just so hard to reach students like that. If they're not gonna, if they're not gonna show up to stream and not check their email, I have no way of contacting them. So if anybody in the course, reach out to them, get them filling it out. And this question was asked on Piazza, just to make sure everybody knows, the percentage does not include students who've dropped or resigned the course. This is only the students who are still with us, still either working towards passing or starting to submit and accept the F. But they are students who are getting a letter grade in the course, just so you know. Or else we would never get a 90%. Okay, anyway. Is everyone passing this class so far? I wish. Everybody who didn't drop or resign, I wish everybody was passing still. There's some students with just straight zeros in the grade book still. I have no hope for them. And I've reached out to them through email and they haven't responded. Like, those are the ones who, they're not going to fill out the course eval either. But there's a good portion that I think we can get at least close to 90. We can get there if everybody really works to fill that out. Takes the couple of minutes to fill it out. How many dropped or resigned? It's roughly, I think, high 30s, about 40%, I think, dropped or resigned, which is way high. I don't want that to be so high, but it's we lost a lot of students, I think, just because of being remote. Anyway, we got to get into review. That's what y'all are here for. Let's do some review. So, based on the Piazza responses, the biggest responses, I know it's a lot. That's a lot resigned. But I think what a lot of students do is they sign up for more courses than they can handle, and then whatever course is the hardest course of their semester, that's the one they resign from. And 116 is often going to be your hardest course of the semester. So this is the one that students resign from, because just as part of their plan, which I can't blame them. To be honest, I've done the same thing as a student before. I register for too many classes. I know I can't handle them all, and then as the semester goes on, I just decide which one's the biggest pain in the ass, and that's the one I resign from. So I can't blame them, but man, from the other side, when I'm looking at that 40%, it sucks. It sucks. All right, so the highest voted was 4.2, lecture questions 4.2 and 4.3. So let's start there. It's got 7 up votes or helpful answers. Technically, Piazza calls it. But let's talk about these ones. 4.2 and 4.3 is where I want to start today. And feel free to ask follow-up questions and ask questions about other things. I'll keep on track. Based on the Piazza responses, I want to do at least an overview and hints and things like that for 4.2, 4.3, 4.4. And I'm looking at my notepad over here where I have all these noted. 4.4, 3.3, which I'm surprised didn't get more upvotes. That's a tough one. And 4.6. Hopefully we can get all that. Get all that done today. So I'll try to spend like 5 minutes on each, kind of talking about the relevant lecture content for the lecture question, reinforcing any of the concepts that are being tested, and anything that I think might help you. 3.3 also had 7 votes. It might have just got an extra vote before I recorded that. It had 6 when I recorded it on my notepad. Hope you never have to take... Oh, you're talking to someone else. Register for 18 credits this semester. And bio was the hardest. Hey, a course harder than 116. I like it. I don't like being the hardest course, because then you get your course gets that reputation. I don't like having that reputation of, oh, you're 116. That course is, you're going to die. I like it being known as a challenging course, but when it gets a little, the reputation is a little out of hand, I think. But anyway, it's not what we're here to talk about. Focus, Jesse, focus. So this lecture question, the backlog lecture question. So the idea of this is to implement a queue. And for this, one thing that we found with 4.4, discussing it with chat Monday, was that a lot of students, the students that were struggling, I shouldn't say a lot, but the students who were struggling were tending to overthink the question and doing a lot of work that they didn't have to be doing. So I suspect that might be the problem with this one as well. You don't have to actually implement a queue. Like, I'm not asking you to take our linked list node. Do we have that in here? I'm not asking you to take the linked list node, implement a queue, Like I give the lecture content as background, but I don't expect you to implement a queue like this or use a queue. You can of course use my queue class. There's nothing wrong with that. But I'm not asking you to re-implement the functionality of this. If you just want to use Scala's immutable list for this question and append to the end of the list and then pop from the, DQ from the front of the list, it's inefficient. But in this course, we're really not concerned about efficiency. A lot of the lecture content in this lecture was in preparation for 250. So you should know that that's inefficient to use a queue like that. You can't use a singly linked list, which is the only type of linked list we studied in this course. You can't use that efficiently for a queue because you can't push and pop from both ends and not have to iterate over that queue. The one we implemented was efficient, but we did a little bit different things. We kept a reference to both the head and the tail of the linked list, so we did things a little bit different. And with Scala's built-in list, since it's immutable, you cannot build an efficient queue out of that data structure. So regardless, if you just want to use Scala's built-in immutable queue and have an O of 1 or an O of n operation in there, that's perfectly fine for this question. The other parts, the type parameter and the first order function. So we have a constructor. Whenever we create one of these, we have to give it a type parameter, what the type of the backlog is going to be, and also a function, could technically be a method, that's going to take a value of that type parameter and return unit. So this is just a function that we want to call on anything in this backlog that gets complete. So the backlog is going to be a queue where we add tasks to it, and then we can complete tasks as they come. So if we have this queue as our backlog, once we get there. So say this is our backlog. We add a task. I mean, it doesn't make so much sense with ints, but we add a task -5, we add a task 2, we add a task 7, we add a task 3 to our backlog. And then we say complete a task. The first task that needs to be complete is -5 because that's the one that's been waiting the longest. So this is like waiting in a line for an amusement park ride or at the DMV or wherever you have a line. If you're first in line and you showed up first, you better be the first one to be served. So that's the same thing we're doing here. The first one that shows up needs to be the first one that's done, and then the second one, then the third one. Then if we add in the middle of this, those are going to be added to the end and waiting even longer. So if you're using a list, you should append to the end when new tasks come in, and then remove from the front, remove that first element from the front with that. And with this one, this did have a bonus slide. I think this is really helpful in your testing. Is for your testing, you should create a class that actually makes sense to be used with a first order function in a way that you can test that functionality. So I gave this code to help you with your testing. If you turn this into a unit test with asserts, I think that's the easiest way to make sure that you're building this properly. So when you have a lecture question, make sure that you're struggling with. Make sure you always check if I have bonus slides. I rarely show them in lecture. I'll show them this week though. So for this, I created a class named email, and if you do testing like this, make sure this class is defined inside of the same file as your unit test. Because if it's not in that same file, it's going to be deleted by my code when I replace your solution with my solution and then run your tests against my solution. I should double check. You did have tests. Yeah, you did have tests for this. So if you're getting errors in Autolab, that might be the case. You might have this class defined outside of your testing package. It can be in a separate file as long as it's in the testing package. And in that directory, it's not going to be deleted. And then I have my first order function, which is actually a method in this case, that's going to just change some state of objects of this type. I'm just going to flip a Boolean from false to true. So I'm not doing any complex computation. I'm just doing something that I can test. So I'm adding a backlog, doing a backlog with a bunch of emails. And we have to set up something else for testing. So for testing, I would want to take a couple of these emails, at least these 2 emails, the first 2 added to the backlog, and at least one, probably the next one. I would at least want to store these first 3 in separate variables, so I have references to those emails. I add them to my backlog, I complete 2 tasks, and I would expect these 2 emails to be complete. So in my asserts, I would go to my variables that store references to these 2 emails, or these 3, make sure that the first 2 have a dot checked of true, and the third one has a dot checked of false. That way I know that that first order function was called properly on those objects. That would be how we want to test this one. So let me catch up with chat. Are there any specific questions about this lecture question? Hopefully that cleared some stuff up. Tried and failed? I hope you passed, and I appreciate the comment here that I couldn't make the structure any easier. I think I'm getting more nitpicky, but I think it can be better. I can get better structure in here. But I do appreciate that. I like to know that. I think the organization and presentation of material is one of the biggest things that I can do to help make the course seem easier. Even if the content isn't getting easier, I can remove the artificial difficulty. Like if you have a course where you can't even find where the assignments are or where to submit or how to submit. If submissions are on UB Learns, I almost got a 0 for an assignment because I submitted to the wrong place on UB Learns. Luckily, it was a partner project. We were working in teams of 2. And my partner's like, yo, you submitted that to the wrong place. So luckily we caught it, but I don't think I have that kind of stuff. So I'll do it. I hope we survive next semester. Like this last semester wasn't too bad. The remote part of it, we spent most of it just adjusting. So at least for me, I was kind of distracted most of the time because I was just figuring out what the hell to do. This semester is a war of attrition. It's just holding out for a whole semester, especially knowing next semester is also remote. So next semester is just going to wear us down even more. This was fine for 7-8 weeks last semester, but now we're a semester and a half in, remote only. And I've said this before, I'm doing okay with it, I personally, but then I have so many students who are struggling with it, and then that wears on me. That's the part that's getting me the most, is seeing so many students just completely struggle with remote only. So today's review for whatever you want, but the Piazza posts, what people suggested on Piazza, were mostly about lecture questions. So it's going to be lecture question review. If you want something else, just post on Piazza and get people to upvote it. This week is the week we have a result from email about we are passing the class and no exam, or did not pass the class and take the final exam because we missed one lecture question. That'll be over the weekend, Nash. So lecture questions are due Friday. So after they're due, midnight Friday, well, technically midnight Saturday, that's when I can start processing that. And then over the weekend, I want to get those emails out. But I can't do that yet because, I could send it to some of you, those of you who have everything finished, but I think you already know that you have them done. But anyone who falls short of the lecture questions and doesn't get them all, I have to make a decision of what to do with you. Because technically, you failed the course at that point, but I'm not just going to fail you if you're close. If you have your labs, you have your interviews, you're missing, 3 or 4 lecture questions, I'm going to come up with some plan for you over finals week to figure out what you need to do. Where can I find the course evals? Check your email. You have an email from me yesterday. You should have also a few emails from the eval site itself that they've sent you the links. But check your email. If you don't find it, come back to chat and I'll let you know. And there's the link. PJB's got you covered. No questions about this lecture question? Is anyone who needs lecture questions still here? I hope you are. Or maybe they'll watch the VOD. But none of this chat is about lecture questions. I'm still going to go over them because that's what Piazza told me to do. Wish class had more time for lectures. Yeah, I think that is one thing. But again, most of the class, I can't get them to watch the lectures that are out there already. So I don't know how much that would help. I'd be happy to just do more lectures. I know I always hang out after lecture. But yeah, if we had quarters instead of semesters, yeah, that would help. If you miss a full learning objective of lecture, hey, here's the chat. Thanks. Yeah, let me know what you're waiting for, because I'll move faster to get to those things. What happens if we miss a full learning objective of lecture questions, or just don't pass most of them testing for them? So there's a few big differences here. If you fail, if you don't get any of the lecture questions for a learning objective because you didn't submit any of them, I'm probably just going to say here's your F. If you miss a full learning objective of lecture questions, but you've submitted for all of them, and each one is only missing like one test case, and they're all very close to passing, that I'm going to work with you, and we're going to get you across the finish line. I'll have something for you during finals week that we're going to get you to a passing grade if that's the only thing preventing you from passing the class. But I got to see effort from you. That's the big thing that I'll be looking at this weekend when I say, okay, this student was short on their lecture questions. How much effort did they show me? They've had an entire semester to do these 30 lecture questions. Did they make an honest effort? It's going to be similar to my assessment for extensions on homeworks. Did you show me an honest effort? Did you actually try? Or did you just kind of half-ass it and then say, oh, Hartloff will give me something. He'll give me a chance during finals week. So show me that you've tried, and I'll work with you. I don't want to pass anyone, or I don't want to fail anyone just because of some, you didn't quite get there. We're going to get you across the finish line if you show me the effort. I need 4-4, 3-3. Both of those are coming up. 4-6. All those are coming up. 4-6 coming up. Cool. Let me get to those ones then. So I guess nobody here really wanted 4. Well, you wouldn't say you needed 4-2 if I already covered it. And 3-3, I definitely want to get to that. I expected more votes for that one, actually. So let me quickly get 4-3 done. Nobody called for that in chat. So let me quickly get this one done. The expression, because I did this yesterday. Expression trees, the big thing is that this is a post-order traversal to evaluate an expression tree. So what you want to do, this is one that people were overthinking. You don't have to do infix expressions, postfix expressions. You don't have to do any of that stuff. Just recurse through this tree with a modified post-order traversal and compute the answer as you're traversing the tree. So each time you have a node, if it's an operand, return that. Just say 2 double and return that as a double. If it's an operator, make your recursive call to the left, recursive call to the right. Get the doubles, get those results as doubles, and then perform the operation and return that. So the root node, by the time that returns, this will be a double, subtract them, return, you have the full answer. Don't overthink this one. 4-4, which for some reason I didn't open. 4-4, I believe is 2 list. So this, similarly, this is an in-order traversal, is the idea of this. The tricky part of this is the return value of the recursion. So what do I want to point to say this? The return of 2 lists is going to be a list. Let's go to IntelliJ for this one. Is going to be a list where did that end up? I'll find this. I'll find it quick. Will I find it quick? I'm trying. Oh, I used all kinds of stuff for that. Oh, yeah, I used all kinds of other stuff. But our recursive calls are going to return a list. The base case is this node is null. So I don't know how much this example will help. Let me go back to our traversals. So if we traverse a binary search tree using an in-order traversal, we're going to visit the nodes in sorted order. And that was part of the lecture example. So we know we want to use an in-order traversal, but we have to modify this to return a list of A's. So we want to return a list of A's, and when we're visiting a node, our base case is going to be is implicitly here in the in-order traversal. Our base case is the node is null. There's no else because we don't have to do anything when the node is null for an in-order traversal that's calling a function on each value. But for our toList, we're going to want that else. Say, if this node is null, what's this tree? If this node were the root node, what would this tree's representation be as a list? And that's the empty list. So return the empty list. And then the recursive step, so our base case is done. Our recursive step is to make the two in-order traversal calls. So call toList on the left and right. No, we didn't do 3.3 yet. Do call toList on the left and right. And you have the value that this node is storing. So this toList call is going to return a list. This toList call is going to return a list. And then you have to combine this list in front, put this value in between the two lists, and then this list at the end. And if you want to combine two lists into a single list, use the triple colon function. So if we want to prepend one value, for example, you could prepend this value to the list returned by this recursive call using the double colon to prepend. And then that gives you a list with all these values. And then use triple colon in between in-order traversal, the first call to toList, and this new list that you just created. Use a triple colon, combine those two lists. That's what you return. Up the recursion, and that's pretty much the whole solution. I just went through the whole solution there. For 4 is the one I just talked about. Are we on 3.3 now? Yeah, those expression trees, and yeah, this was toList. Yeah, and we're on to what I think is the big one. I think I have to nerf this question next semester. It's just a little too much. It's too much trickier than the lecture examples. So I don't really like this one. You have the test cases already from your old factoring question from back in Learning Objective 1, and especially when it's in Learning Objective 1, it's a little too tough. It's a tricky one for a lecture question. So you have your testing, which includes sorting the return values. It's satisfying to finish for sure, but easy to get frustrated. Could you go over the completed task not removed test for completed task not removed? So it does what it implies. When you complete a task, it's still in the queue. It's never dequeued. So as long as you're calling complete task at least twice and testing to make sure it worked properly, you don't even have enough testing. You don't even have the testing that I give you in the bonus slide if you're failing that one. Take the bonus slide and do the variables like I said earlier and test all that, and you should get there. You should get that one covered. Yeah, it took fun and rewarding, but took 8 hours to do the first one. Yeah, it's just a little bit much. If it's more of an optional thing, if you have other options, but I force you to do these ones, it's a bit much. That's where I lost a lot of students, was the first factoring lecture question. factoring, and then alliterations had a little trick in it that was a little too tricky. For this one, okay, this is one I do want to go to IntelliJ. This is the example that I had open up here. Is what might help for this is looking at the binary conversion algorithms, methods that we had. We have values, we have ints, we want to turn into binary strings. And the key thing that we did here was our base case is some trivial, either it's just 1 or 0. It's already in binary format. And in the recursive case, we wanted to somehow get one of the values out of this and then make a recursive call on a smaller int for the next call. So we want to think of this, it's a bit trickier for factoring, but we want to think of this same idea. In the recursive case, we want to look for one factor. That's our goal in the recursive case. If we can just find one factor, we can make a recursive call to factor of the number that we currently have divided by the factor that we've just found, and then append, that's going to return a list, and then append or prepend the factor that we found. So say we were factoring some integer, we find that 2 is a factor of that integer. What we're going to do is make a recursive call of that value divided by 2 that returns a list. We're going to assume that our recursive call is correct, that is going to give us, like for a more concrete example, say our input is 8. Say our input is 8. We're going to make a recursive call on 4 and assume that gives us the prime factorization of 4. So we're going to assume that this returns list of 2, 2. So if our recursive call returns that list of 2, 2, what we can do is append or prepend, in this case, the factor that we found in this recursive call, or in this recursive step, to that list that's returned. Make sure that our base case is returning the right thing, which for factoring would be an input of 1 is going to return the empty list. And always append that one factor at a time. So this simplifies the problem down to writing a recursive step that's going to find one factor. To find a factor, there's a few different approaches you can do here. You can have some creativity here. You can have another recursive call which recurses through all of the possible factors. So you want to typically start at 2 and keep incrementing 1 and check the next factor until something divides this thing. Since your base case is 1, you can assume that there exists a factor. So you will eventually find one. And to be safe, you could have your base case less than or equal to 1. I actually might have to based on the way I word the problem. And look for one factor. So you can have another recursive call which finds a factor which has a second parameter, helper parameter, which is the factor that you're currently testing. So you call your factor helper with the value that you're factoring and 2 as the factor that you're going to check, the potential factor you're going to check. In that method, check if it divides it. Does this divide 2? I feel like I do this somewhere here. Does this divide... is this divisible by this factor? Is this actually a factor? If it is, return that factor. You found a factor. If it's not, recurse by adding 1 to the factor you're going to check. So make a recursive call to the same method that checks 3 instead of 2. Make a recursive call that checks 4. Make a recursive call that checks 5. You get fancy and only check the primes if you want, but that's a bit more than you have to do. And then keep checking each factor one at a time. And then once you finally hit the base case, just return it back up. That's one way to do it. Or you can shortcut it a little bit and iterate. Just have a loop that starts at 2 and goes till, I like to do the input to the input that you're factoring. And once you find a factor, check if it's a factor. Once you find a factor, you can kind of cheat a little bit. It's not really cheating, but it's not the best practice. Use a return statement and say, okay, return the recursive call appended to the factor that we found. And it can prevent using a second recursive function. There is, let me just check real quick. I know I've used that before in a lecture example, in one of the pretty complex ones. I don't know if I'm going to find it. I might not have even pushed it to the repo. Yeah, it's possible it never made it to the repo. Okay. So let me check for questions about factoring. A lot of call for that one. Did that help? Are we feeling okay about it? You want to spend more time on this one? My laptop's burning up. Chrome. Yeah, prime factoring LQs were the toughest. I think they are too. I have to nerf those next semester. Either have to nerf those or make every lecture question that tough. But either way, it's a difficulty spike, and I gotta get rid of that. Because you're not expecting that, especially when it's, I think it's 1-3 when I hit you with factoring. Or is it 1-2? I think it might be the second one. The second one for credit. Yeah, 1-2. You're just not expecting that. It's just too early for something that hard. And then I think what happened is a lot of students got it in their head that, whoa, this is how hard every lecture question is going to be. And this is only the second one. They're only going to get harder. And that's just not the impression I wanted to give. I didn't want it to be trivial because I wanted the class to make sure they took lecture questions seriously, but I went a little overboard. But it sounds so easy. Oh, factoring. You know what factoring is. Just factor. But it's not as easy when you're still struggling with Scala syntax. That's a bit too much. Because you forgot to put server.start. Oh, Mega Mutiny. Yeah, you can do it without a helper method too. There are a lot of ways to do it. I think some students even found a built-in function that just factors for you. If I catch you doing that, that's not going to be good. But there are even simpler ways to do it. Or you could use some fancy methods like reduce and things like that. There are some really interesting ways to solve it. Hey, we hit 56% response rate. We're getting closer to that 60. Yeah, exactly, PJB. I don't want 1-2 to be that. That's got to change next semester. As a math major, I like having math majors in the class because they give that perspective like, yo, you should see my math classes. This is nothing. All right, no questions about this lecture question. All right, there's a lot of call for it, so I'm going to assume my explanation was solid. I'm going to assume that helped since there are no follow-ups. Okay, 4-6 is the last one. Hey, we're doing all right on timing too. 4-6 is the last one that I wanted to make sure I covered in this lecture, so let's hit it. 4-6 is your last uncompleted lecture question. Well, I'm so lost. Let's get you across this finish line. Let's get you to 30 of 30. So, find the distance between two nodes in a graph. This one, did I give a bonus slide on this? No. So this one is made to lead into Maze Solver. 4-5, 4-6, and then Maze Solver were all a progression. That was basically a 3-part progression to get you to really understanding how to apply breadth first search. And that's exactly what this one is. Take my breadth first search algorithm that I give, which I kind of regret. I should make you implement breadth first search in this class. I think that was on Piazza, right? I got a complaint of, no, it was in my email, of some of this. Actually, no, that was LO5. Never mind. Let's just talk about the lecture question. So take my breadth first search algorithm and modify it to be able to find the distance between two nodes. So I would assume if you're stuck on this question that you haven't done Maze Solver. If you have done Maze Solver, take whatever code you did there to find the paths, and then just find the length of the path, and you're done. The length of the path would be the length of the list of your path minus 1, because the length is going to be the number of nodes, but the length of a path is the number of edges. So if you've done Maze Solver, just use your Maze Solver code and hit a dot length minus 1 and you're done. If you haven't done Maze Solver, which I would assume you haven't if you're still on this lecture question, then you want to take my breadth first search algorithm. I don't know what I'm scrolling to. It's not going to be in here. Actually, I think it is. I guess not. It's going to be in 4.5. Maybe I do never show. Oh, here it is. So take my BFS code and then modify it using one of the ways that we saw in 4.6 to be able to get the length of that path. So we did the distance example here. I would rewatch this part of lecture where we remembered the distance for each node and add that in a data structure like this to be able to remember all of those paths, or not the paths, but the distance to each node. And using my BFS, I actually give more in the code that I hand out than I provide in the lecture slides in that code. I actually do have this named distances, but doesn't really do distances. What this map does is remembers where each node came from. So this is going to map a node that was visited to the node that it was visited from. So you could use this to backtrack and build your paths. So this is really helpful for the Maze Solver homework. Or you could modify this a bit and have it do distances. Instead of start ID, initialize that to -1, meaning indicating the start. Just reuse this map to actually be the distances. The start ID to itself is distance 0. And then when you update this map, instead of mapping to the node that explored that node, map it to, not to just completely give it away, but the distance of the node that it came from plus 1. Why are you giving me an error? Oh, because I have parentheses here. Just the distance of the node that discovered it plus 1. If that doesn't make sense, you have to study the BFS code and how this code relates to the examples in lecture to get the to really see what's going on with that one. But really, taking this BFS algorithm, I would take this, copy that into your code, because this returns unit, but you need to return distances. Copy that into your code and then start modifying it to be able to return the proper int that you discover through the run of this algorithm. Yeah, 4.6 is tough because you can't hope to complete Maze Solver without it. Yeah, that's the idea. So I hit you 3 times with applications of breadth first search. And if you can't do the distances one, you don't have much hope for doing Maze Solver. And this is something I didn't make, Dennis Grace, this is something I didn't make as clear as I usually make it clear every semester, and then I just started taking for granted that I assumed every student knew. But anything in my examples repo is fair game. You can take any of that code. It's not academic integrity violations or anything. You don't have to re-implement BFS. Anything I give you in that repo is fair game. You can paste it into any lecture question, any homework assignment, your project contribution. You can paste that code wherever you want. For things outside of this class even, I'm fine with that. If you want to use something that I gave you as code, I'm giving you express permission right now. You can use all of that code. It's all fair game. Anything I put in that repo, I put it there expecting like that this is code that I am handing to students for you to use for whatever purposes you want. No copying from that is never academic integrity violations, which is why I don't give you solutions to lecture questions in there, because obviously you just paste them. But I give you code that's similar to what you need. You can use that as a starting point in some cases to be able to get there. You mean BFS being in 250? I don't know what you're referring to. Using that's causing controversy in 250. Andy and I have talked about that a few times. Whether you can use my BFS code in his CSE 250. I believe he's been allowing it, and I allow it as long as he's okay with it. But students learn less about BFS if you never implement it. I think it's between the two courses, at some point you should have to implement BFS so you get a better understanding of what's going on with that. And during the LO5 interviews, I'm seeing that as well, that students don't really have a good understanding, at least the ones I've been interviewing, a good understanding of what BFS is doing. They can explain it to me like we've seen it in the slides, but if I ask about more specific details, their answer might as well be, I don't know, I just pasted your code, bro. I don't know. I might have to change that in a future semester. And that is all the lecture questions that I wanted to go over. 2:40 is the ending time? Yeah. You'd think I'd know that second to last lecture. But so I did all the lecture questions I wanted to get through. It's perfect. And unless there's big changes on Piazza, applications of BST and 3-6 are the next ones on the docket. Applications of BST, I don't have a ton to talk about with this. I might as well do this one right now as well. It's the one non-lecture question one, so I'm excited for that. But unfortunately, it's one that I just don't have a ton to say. But applications of binary search trees, the biggest one is when you have dynamic data. So, for example, if you have... I don't know if I do like that example. That's the example I was going to go with. I'll run with it anyway. Maybe you have a lobby for a game, and... Actually, I do like this example. You have a lobby for a game. You have hundreds of players waiting, or thousands or millions of players waiting to play a game. And you want to organize these users in some way. So maybe they have some gamer score or some ranking that you want to sort them based on, and then take the highest ranking players, put them in one game, the next highest ranking players, put them in another game, etc. So you need some sorted order, but you also have players entering and leaving the lobby constantly. So we can't just keep running merge sort on this group of users every time somebody enters or leaves the lobby, because every time we hit merge sort, we're going to be doing an n-log-n operation and sort this entire group of users every single time there's any change. So we have dynamic data that we also want sorted. That's the specific application of BSTs. So with BST, we can insert and remove in log-n time. We didn't in this class, but you will in 250. We want to insert and remove in log-n time while maintaining the sorted order. So if somebody enters the lobby, we know exactly where they go in that tree in log-n time. We add them in that spot in the tree, but we didn't have to run a full sorting algorithm. And now whenever the game starts, we can organize these people into their respective groups quickly. We can very quickly find, okay, here everybody in this subtree is a higher rank than this node, so they're all going to go in one game, etc., and go through the whole tree like that. So that would be one place where it could be used. Really, anywhere where you have dynamic data, where you're adding and removing from your data structure, and you need to maintain order. That's the big application, is whenever that has to happen, whenever those things have to happen. All right, with that, that's where I'll officially end the lecture. So anything I cover from here on out, even if it's in the Piazza post, I'll cover it again on Friday, time permitting, if it's highest voted. So even if I cover one of the next highest voted things, like 3-6, I'll still go over it in Friday's lecture.